Hello, this is Chris Gibbs with Veracity. Thank you all for attending our October demo of the Veracity Flow Controller. I'm going to turn it over to Jeff Smith now, and he's going to show you some new capabilities, new user interface, as well as go through some of the standard value and standard capabilities of our Flow Controller. Jeff, over to you.
All right, thanks, Chris. Morning, everybody. Our normal host, Carly, is not in this morning, so I appreciate you jumping in, Chris. For some of you, this will be review. I think some of you are somewhat familiar with the controller. For some of you, this might be brand new. And so we're going to walk through a PowerPoint with a few different ideas to kind of convey the concept of SDN. Then I'm going to show you the SDN controller on a small network. And then I will show you and walk you through, with as much time as we have left, the new UI. So our 3.0 version of our UI, which will be released in the near future, which has a lot of functionality, a lot of things we've done to it to give us the flexibility to do some really cool things in the future. Plus, kind of improving, over the last year or two, we've learned a lot in terms of troubleshooting and what helps and what works well. So we've added that functionality to the UI as well. Also on the call from Veracity is Jason Abosky, who is our QA lead. So whenever anything goes wrong, remember the name Jason Abosky. You're welcome, Jason. All right,
and every day it goes right, remember the name Jason Abosky.
That's right. That's right. All right, well, we'll get started. So with OT networks, I've been around the block a little while. Some of the guys on the call I've known for 20 some years. And for a long time, I was in their role as an end user. In fact, I spoke at S4 a couple of years ago, and I did a session on what would I have done differently in 2006 when we moved as an end user to Ethernet IP if I would have had SDN then. And so it's a really kind of an interesting story. So there are so many different things that I would have done differently. And I think in the long term, it would have helped. SDN's been around for 12 years now, I would say. It's largely deployed. In fact, it's almost 100% of the cloud space or cloud infrastructure. So your companies like Google's, Intel's, Apple's, anybody with a cloud, Microsoft heavily uses it. It's kind of rolling through the enterprise space. So a lot of enterprise organizations are moving towards a software-defined networking architecture. And the reason for that is obvious. They don't want to have to pay Cisco $1 bazillion every time they need to change the way their network works or what can connect to what and where. So by doing it with software-defined networking, you have more of a centralized control of your network, and you have the ability to quickly address or make changes to the network as needs dictate. So it makes it very, very handy. So when we talk about the network controller, it really is. Let me click my screen here. It's a different way to manage the network. And I think what's important to note is when you look at a lot of the other solutions out there, they're either a tool that sits on top of the network, which means it adds to the network overhead, it adds to the load on the network, or they're a tool that's very proprietary and you have to have a special device hanging off your switch, which connects to another special device at the other end. And if that technology is not available or it changes, you're somewhat beholden to the company that you bought it from. In the world of software-defined networking, and in particular with the implementation that we've put in play, it's a standard. It uses a protocol called OpenFlow, and it is an industry standard and open standard. So there are multiple companies that make switches that support OpenFlow. Allied Telesis, Schweitzer Engineering Laboratories, Dynix, Cisco, to name a few. Now I happen to be partial to the Dynix switches, but that's for obvious reasons. And I'd be happy to explain to you why. But the key takeaway is this is the same Ethernet that you're using today. It's not new, it's not different, and it's the actual network fabric. So when you see changes, they're in nearly real time. You see things happen nearly real time. When you look at the topology and devices are showing up, it's because literally someone just plugged something in or somebody just powered something up. This is not a separate application running on the network. It's the network fabric. I think another big takeaway is complexity. When we look at networks today, if you've got lots of VLANs in your system, or you have spanning trees or PVST or specific, ring protocols, with SDN, those aren't necessary. That you don't need them. VLANs in particular, right? If you guys have ever had to configure networks or help customers configure networks, or if you are the customer in configured networks, VLANs are complex, and their whole purpose is segmentation. Well, in the world of SDN, it's a micro-segmented network, so it's already vastly more segmented than you can get to with VLANs. I will ask that if you guys have questions, feel free to put them in the chat channel, and when we get to the Q&A session, we'll go through those questions and answer them. Chris, can you help keep track of that, please? And I think lastly, one of the important features that I ran into as an end user was loops. It's not uncommon for cables to get unplugged here and there and for things to happen. So when that happens and they plug it back into the wrong place, it's entirely possible you can take your network down simply by creating a loop, and a traditional network has no protection for that. In the world of SDN, I could go absolutely crazy with how I plug cables in, and it's going to work. It's not going to allow a loop in the network. So we talked a little bit about micro-segmenting. The mechanism for that segmentation is called a flow. And the cool thing about SDN from an OT perspective, and we're really the first company to implement an OT-centric controller. There are a few people that are talking about it, and they've mentioned it, but I don't believe they have any of them in production, which we do, both in the defense industry, manufacturing, as well as water, wastewater management, and some municipalities. So the concept of this communication is called flows, and it works the way we think on the plant floor. Instead of, well, I need to know I need this VLAN on this port of this switch, and if I don't have a cable plugged into that port, then this VLAN over here needs to be trunked to that. All of that goes by the wayside, and it becomes as simple as, I want this PLC to talk Ethernet IP to this IO block. And that's all you have to know to make it work and to secure the network. I generally tell people it'll take me about 15 minutes to show you how to manage the network. So how does it work? So it's deny by default. If you guys know me at all, and some of you do, I stand on deny by default. In a traditional network, in the IT space, for example, they have to allow everything except that which they suspect to be bad or know to be bad. That's just the way they have to operate. In the OT space, we should allow nothing except that which we explicitly know to be good. So all of the products that I'm involved in typically are denied by default. That means nothing can talk to anything unless you explicitly allow it. So, for example, I want the PLC in the lower left corner to talk to the HMI in the upper right corner. So the idea here is I'm going to allow Ethernet communications between these two. This is the first picture, so everything else I was just kind of talking to it. So if I'm allowing Ethernet IP between those two, this happens to be a ring, could be a star, could be a mesh, right? I could run any cable I want between any switch I want. The controller is going to calculate the fastest path between those 2 points, and it's going to lay in what we call flows. So now, in those 3 switches along the path, and I'm pointing at my screen, so you guys will see me do that with this camera. You'll see me pointing at you the whole meeting. It added the necessary flows to allow that to talk. Nothing else on the network can talk. So I could try to ping that PLC from that HMI. That won't work. I have not allowed ping or ICMP. I could try to get to the web page via HTTP on that PLC from the HMI. That will not work because I have not allowed HTTP. Literally, the only thing that will work is SIP or Ethernet IP. Okay. Well, what happens if that breaks? Right? If a path between endpoints is lost, the controller recalculates and knows the next fastest path. So it will immediately modify the switches in the appropriate path to allow that traffic to flow, and it will remain largely uninterrupted. So that gives you the ability to have built-in redundancy. We have a feature that we're going to be releasing in the not so distant future that is actually going to provide us, right now we have millisecond failover, it will provide us microsecond failover. So it'll be very, very, very fast. And a lot of that has to do with the work we're doing in the substation and electrical fields. They need microsecond speeds of failover. So we're implementing that functionality. Also, what if a device is moved? Any of you guys that have been in manufacturing for a while, for example, when you're starting up a line or you're starting up equipment or you deliver equipment to the plant, hopefully the manufacturing process has been figured out. I'm not going to ask for a show of hands for those of us who have been around when it's not been quite figured out, because that would be all of us. So if you go to all the trouble in a traditional network to set a security posture where you want things to be just so secure, and then they rebalance the line completely, well, now you've got stuff plugged into this port of that switch on this VLAN of that port of that switch. All of that has to be changed. You've got to go back and go out and reconfigure switches. In the world of SDN, if a device moves, for example, the controller will immediately notice the move, it will log the move, and it will adjust the network accordingly. You've already said at this point that PLC is allowed to talk to that HMI over Ethernet IP. You don't need to be involved in enforcement or changes to the network to make that happen. The controller will make the network work the way you want it to work, and it will keep it from allowing things in that shouldn't come in. All right. Now, allowed traffic. How has that specifically happened, or handled, I should say? When traffic is allowed, if it's known traffic, so in this case, we're going to talk about Ethernet IP. If the traffic is already known and there's a policy that allows it, then the switch already knows those two devices are allowed to talk. There is no traffic. Nothing goes to the controller. Those two are simply allowed to talk. So the packet shows up at the switch. The switch says, I already know what to do with this. I've been told these two guys can talk over Ethernet IP. And the two, NetRunner and the PLC, commence to communicating. Okay. Now, the very first time that happens, you'll see a log message. So you'll get a nice detailed audit trail of what's happened to that device, when it started talking, what protocols it started using, right? If I have allowed traffic on the network that I've never seen, so let's say I create a policy that says anything can talk Modbus TCP to a NetRunner. Maybe that's my policy. Maybe it's a really broad policy like that. But I've never seen this particular PLC on the network because they're just powering up OP90 and it's never been on the wire before. In the world of traditional networking, I've got to go to the switch. I've got to make a bunch of manual changes. I've got to adjust the switch, allow this, do that, excuse me. And really, if it's east-west across a single switch, you don't have much control on the security from a security perspective, unless it's SDN. In this instance, what's going to happen is the switch is going to see that first packet of Modbus TCP show up from a device that's new, and it's going to say, Mr. Controller, I have this Modbus TCP traffic. What do I do with it? Controller will evaluate its policies. It'll see that policy that says all things can talk to all NetRunners over Modbus TCP. It will create all the necessary flows along however many switches are in the path. And then in the future, the NetRunner and the PLC can talk and the controller's not involved, right? We'll get a nice log that says this PLC at this port of this switch started talking Modbus TCP to this NetRunner on this port of this switch at this date and time. But at that point, the controller's out of the picture. The beauty of this is the controller is really just there for visibility and handling anomalies, right? Once the network is up and running, there's very little activity or very little traffic or very few things that the controller and the switches are doing from a communications perspective. You can actually take the controller offline. The network will continue as normal. It's not going to stop. You can power down switches. You can power them back up. When they come back up, everything will continue working the way they're supposed to work. So it makes it very, very easy to add devices securely and to manage those devices in the long term. Now, what if you have traffic that you don't want? For those of us that remember, and it's much better than it was today, but back in 2007 or 2008, if you plugged a device that was using Profinet, or let's say you had a supplier come in and the supplier had a Profinet driver on their laptop and they plugged into your Ethernet IP network. very frequently did we run into occasions where that would take the Ethernet IP network down. But having the ability to explicitly block traffic might be, okay, I have maybe I'm in powertrain, I use Siemens and Profinet, then I'm not going to allow Rockwell. If I'm in assembly or body and white and we use Rockwell, then maybe I will not allow any Siemens traffic on my network. So you can explicitly block traffic types, right? And so in this instance, the first packet of Profinet shows up. The switch is going to tell the controller, I've got a block flow that says this can't happen. Log that someone tried this, that on this port of this switch on this day, this device with Profinet tried to talk to this device on this port of this switch, and the traffic was blocked. So we can, quote unquote, pre-stack the network against certain protocols. Now, the question that I get a lot is, why would I do that? If the network is denied by default, why would I bother? The difference is just in the network traffic side of things. So in the case of this example, the PLC sends a packet, tries to send a packet to the nut runner. The switch sees it and says, I don't have a policy that deals with this packet, send it to the controller. The controller says, throw it away. Great. 50 milliseconds later, the PLC tries to talk to that nut runner again. The switch says, I don't have a policy that deals with this packet. I need to send it to the controller. Sends it to the controller. By the controller having a block flow, we call it, the switch does have a policy that deals with packets that it doesn't want. So it never sends the packet off to the controller, thus lowering the load on the network, as well as the amount of work the controller has to do, because like my wife, it's going to look at me and say, I've already told you that 6 times. How come I have to tell you 7? And I will stare at her blankly and not remember that she told me the first 6 times. In this instance, the switch knows. So the switch doesn't have to tell the controller or ask the controller what to do with it. So that's why we would create a block flow. Control and visibility. Think of this as like having a firewall on every port of every switch. And while I really would love for you to put an ICS 360 Deventer on every port of every switch, you and I know that's not feasible. It's not manageable. But with our software-defined networking solution, you functionally have that ability. I can control east-west traffic across a single switch. There is not, to my knowledge, another solution that allows you to do that with any semblance of manageability. So literally, I can control traffic across 2 ports of the same switch, right? That's something that's very, very difficult to do. In the world of SDN, it's doable. Now, we have some customers that have large networks out there. And so these 3, let's call them cells, for example, maybe I don't have the budget to go out and replace, or maybe I've got all unmanaged switches out there. So I need to put a managed switch in or something that supports SDN. Well, I can get started by putting an SDN switch here and replacing this aggregate switch. So now I have east-west control through here on this switch, and I have north-south control, and I have east-west. So I can keep traffic from here, from getting to here, and from getting to here. And that's a great approach that a lot of customers use on brownfield sites, where they can approach it that way. Greenfield sites, in many cases, their spec says, okay, in new sites, we want an SDN capable switch everywhere. In fact, I have one customer that they've put on their spec all of our SDN switches, for example, or our SDN/layer 2. So anytime new programs go anywhere across their 29 plants, they're using our switches because they know when they get to that plant and they want to upgrade to SDN in that site because they're going methodically site to site, all they have to do is enable SDN, and the switches they're already supported. So they're kind of stacking the deck in their favor, which I like. It works great for us. And then we're not going to talk about this. It's managing remote access. So let's just jump over and look at the software. Are there any questions in the queue that I can answer before we move on?
There is one question. You did answer it. Carly, you want to take it?
No. Go for it. No, I just didn't know if you saw it.
Do we need OT network controller connected to network 24/7? Can it be offline and not impact flows?
Yes, the answer is yes. Now, why would you want a controller online? Because it's keeping statistics of what's going out on the network. So Every so often, under normal circumstances, there's not much communication between the switches and the controller, except every so often the switches send something called flow stats to the controller, which are statistics. It's what's going on, how much traffic is moving between these two devices, what protocols are active on the devices, what devices are online, what devices are offline. So if you look at this topology, which this is a very simple topology, right? But if I have a more complex topology, and I have customers that have very complex topologies with, 60 switches and lots of devices, it's nice to know when things go offline visually. So keeping the controller in the loop means I can also see things like logs. So I'll get this type of information, right? New rule created. This is now communicating with this device. So the programming workstation is now talking ICMP to this PLC. Somebody created a new rule. This programming is now converting, SIP. We're now talking with SIP. So you get this very nice audit trail of what's going on. And all of that happens if the controller can see the switches, and the switches can pass all of this information along. Like I plug something into port 6. I moved a device from port 3 to port 4. That will show up in here. All of those things. So it's in your best interest to keep the controller plugged in, but it certainly doesn't have to be there. It will not impact production or your ability to even cycle power to the switches. Once the flows are in the switches, they're sticky. They're not going to leave, right? You'd have to factory reset the switch to make that go away. Okay, good question. All right, so when I look at this, right, and it's a very small network and a very large topology. If I quickly jump over here, I'll give you an example of a much larger network, right? It's much larger, and I could go even larger than that. But for purposes of example, this makes it very, very easy. So when I look at this, I've got some Rockwell PLCs on the network. I've got a laptop that I'm connected to. And then we've got an ICS Defender that allows us to get to this externally, so I can remote into it from remote locations if I want to poke around on this network. And we've got 3 switches. I can do some really interesting things. So like if I go look at RS Links right now, there's my 3 PLCs. And even though I can see the PLCs on the network here, there's no policy in my controller that allows Ethernet IP from this laptop to any of those PLCs. So I can select the device on the network and I can kind of look. I can see that it's plugged into switch B port 8. I can also, so I can get a lot of details. I can see what its peers are. I can collect a switch and I can see that switch A port 3, actually this is my switch up here. And I get some details on that. I can see what device types are plugged in to the network and on what ports. And I can also see what my peers are. So I can tell that switch A is connected to port 3. So that's this way. I know that's port 3. And I can see that switch C is connected to port 4. So I know that coming in here from here is port 4. Okay, so it gives me a lot of great detail. If I wanted my PLC and my laptop to talk, I can click those two. The controller will show me the path that it would take. Now there's a number of ways to allow traffic. The down and dirty way from the topology display is to highlight the 2 devices you want, select control traffic, and then scroll down. And I can see that normally the text says take action, but if it's set to none, that's a little hint to me that it's actually seeing SIP traffic on the network. So what I'm going to do is go to allow and apply. Once I do that, the controller is going to lay in the flows. If I scroll back down, I should be able, well, I can't do this. I'd have to change views. Let's just jump over to links, for example. There we go. Now I can browse that PLC and I can see that PLC and I can do anything I want with that PLC like I normally would. But I can't do the other 2. And the reason for that is I haven't allowed SIP to those 2 devices. So for example, if I wanted to ping that switch, let's start pinging. I haven't allowed ICMP, so it's not going to allow the traffic. If I come back over here and I scroll down to, and I don't scroll that fast, and I take a quick look at ICMP, which is ping, and I allow it, All right, so now I've allowed the traffic. If I come back over here, I can see that I can now ping that PLC, and I can see that PLC from my laptop. If I try to ping a different device on the network, like PLC 27, it's not allowed because I simply haven't allowed ping between those two devices. So I mentioned a minute ago, there's a couple of ways to handle traffic. Another way to handle traffic is I can go directly to the rules and policies. Now, these are the two that were just created. So even though I created them graphically, there's an entry field under rules for those particular devices. I can also create them through something called traffic control. And this goes away in the new UI. And it's also been enhanced in here so that when I double click something and I want to edit it, I get a very powerful window that lets me do a lot of really cool stuff. But let's say, for example, I started pinging 27, but it's not allowed. I can actually edit this rule. And I could say something like any and apply the change. Now I've applied the change. The controller is going out and it's getting packets from that switch that's saying somebody's trying to ping something, and it's telling it no, no, no. As soon as it got the next packet, once I applied this rule, if I pop over here, we can see that I started pinging it because now I've allowed that. If I follow true, I should also be able to do 6. Sometimes you'll even see that first packet get missed in just the feedback from this window because the first packet gets sent to the controller. In this case, it's fast enough and I didn't miss it. The network's not particularly huge, so we didn't lose that first packet when we were trying to detect it. So now I'm pinging that as well, right? And what I can do, I can also take away. So let's start that ping back up. And let's confirm the removal of that flow. So now I've got the flow. So now what's going on is the controller is going out and it's removing any flows relative to ICMP or ping. So it went out to all the switches in the network and it said, any of you that had a policy or rule that was ICMP, it's gone. Can't do it anymore. There's no talking going on. And it stays that way until I choose to change it. So if we follow through with that same idea, I should be able to edit this rule and say allow SIP on device any. Apply the change. And now when I go over to links, and any of you know that it might take links a minute or two to catch up. So we're going to kind of goose it a little, make it kind of go out and browse the network. So you can now see those 3 devices and I can browse them and I can do anything I want with them relative to the network. So it makes it very easy to create rules and priorities. They can be done graphically. They can, once you understand how these work, I find myself in here, and I think most of my cyber engineers will tell you the same thing. They just jump in here and make changes when they want to. You can create policies, so you can have different policies that govern different rules. Another thing the controller has, let's get rid of this, is the ability to learn traffic. So right now, if I go back here and I force links to refresh, right, it's not going to find those. But let's say I'm at a supplier and I'm bringing up a system for the first time. All I need to really do is let the controller learn the traffic. So now the controller is in learning mode. And so what's going to happen is anytime traffic hits a switch, it's going to start writing the appropriate rule. So it just wrote the rule for this because it was being attempted. And in a moment or two, the UI will catch up and it will show the policies for SIP, right, for the PLCs. So here they are, they're starting to come in. And I can see that it captured those devices. And then I can take it out of learning mode, right, go to operational, learn how to use my mouse. Go to operational, and now I've got policies in there for the traffic that was on the network at the time I did this, but nothing else. No other traffic is going to be allowed unless I go back to learning mode or I specifically add. And you'll note those were assigned to a learned rules policy. I can leave them in learned rules. I can move them. I can do all sorts of things with them. I can decide that I don't want learned rules. Another feature the controller has is change sets. So if I'm an administrator, I might make my power user create change sets when they want to make network changes. That means all of the changes they make relative to what can talk to what get grouped together. And then I, as an admin, go in and review those changes and hit apply, and then it lays in all those changes to the network. Other things I can do are with learning mode in particular is, so this is great when you're first setting up a system and you just want to get things up and talking to see what's on the wire. But maybe I don't want that to be that way forever, right? Or maybe we add a new system. You know, it's not uncommon that, you know, phase 2 of a deployment starts in a plant, and maybe they're adding 3 more machines later. So they're plugging in 3 more switches. Well, I don't want to put the network in learn mode, because then if it was blocking some nastiness down in op 70 that I didn't even know was down there because I didn't pay any attention to the logs, if I put the whole network in learn mode, it's going to learn that. Let's say, for example, I've got a supplier in there who's plugged his laptop in and he's trying to stream Netflix through a cellular modem that he also plugged into the switch. That's not allowed. If I put the network in learn mode, it's going to learn that traffic. So if I don't manually catch it and remove it, I've just allowed an adverse, I've allowed adverse devices on my network. So to solve that problem, we would go to our switches, select the switch we want, our new switch, and we can enable learning on just the switch so that it only allows the network to learn what's plugged into the new switch on the new machine, so that I don't have to be concerned about learning the entire network's worth of traffic. Learn mode is a great tool. It is not something you turn on and leave on forever. It's a tool to help get started. But generally speaking, even though this is like the checkbook, right? As long as you have blank checks in the book, you should be able to write checks. No, it has to be something backing it up. And in any good network, there's planning and forethought. If you know you're going to have a PLC in every operation, you know you're going to have IO in every operation, you can pre-build the policies ahead of time so that you never have to learn or use learning mode unless you really run across something anomalous and you just can't quite figure out what's going on, or unless your vendor can't tell you how their device talks. So SDN is a great and powerful way to manage the network. It is not an excuse not to be cognizant of what you're putting on your network when you first start out. Right. That's the problem, is it's that powerful, and you could, but generally speaking, you still want to know ahead of time. That way you can predefine things and you can really have a good understanding of what your network is. I always tell people 6 months after I've deployed a line, it's not what I deployed. It's got new devices. The drawings aren't current anymore. That's where this and the power of this really comes into play, is it helps you keep track of all of that and manage all of that. All right. Other things the controller can do, you can have external applications that reach into the controller and pull data out. We have our Fusion product. We have flows and configuration that allows it to do audits of all of the flows in switches, all of the devices, all of the connections between devices. So it'll do audits and show you any changes. And it's because a lot of companies, particularly utilities, require a third-party audit tool. So the controller will tell you all of that, but they don't always believe the controller, so they use this third-party tool, in our case, Fusion, our own tool, to audit the controller. Other things you can do is you can create zones. So I could create a zone called Final Assembly. So if I create a zone called Final Assembly, right, we'll just go Final Assembly. And maybe I want to create a policy then that's, so let's get rid of these. Maybe I want to create a new rule that says everything in zone final assembly can talk to everything in zone final assembly over, right? Maybe it's kind of a benign thing. So I just want to allow everything in that zone to ping. I'm going to allow it. And I'm going to put it in the policy called default, right? So allow proto ICMP on zone final assembly to zone final assembly. So the question is that going to allow things to start talking? Is this going to start talking? No. Just because I've created a zone doesn't mean there's anything in it. It's up to me to decide what assets belong in a given zone. So if I come down here, for example, what am I pinging actually? I'm pinging 26. So I could take this guy, and I could say you both belong to final assembly. It already did it. I come over here, I should see that they're both in final assembly. So now they're both in final assembly. If I go back to my zones list, I could see the two devices. I can click this button, which doesn't work in the old UI the way it's supposed to, sadly. That's my first demo gotcha, is it should have filtered down to those two devices in this list. In the new UI, it does a nice job. But if I come back over here now, we're going to see that it is in fact communicating because now they both belong to that zone. What's nice about it is if I want to create policy based on zones, or zones is really a misnomer. It's more of a virtual grouping. I prefer the term group myself. I can drop devices into that group, and then any place I use that group, it can work. So it's kind of like an alias in my book, right? Another great word I would use for it is alias. So a lot of times when we talk to customers, we'll say, okay, create a group called, you know, and I'm gonna pick on one of the customer companies online because it's the one I'm most comfortable and familiar with. You have a group called AAM Engineering. Anybody you put in that group, everywhere you use that group in rules, they have those privileges. If I remove them from that group, they no longer have those privileges. So I would do that. I would have a group for suppliers or a zone for suppliers, and I would put people and devices in that. So there's really several ways to manage it depending on how you prefer to manage the network, but it makes it very, very easy to manage and control devices like that. Switch management, you can come in here and you can look at the switches. You can look at, different characteristics of the switches. And, most customers and most folks will never go to this flows list because it's really just a diagnostic tool for us if there's an issue. This is the down and the dirty, down in every switch. Right. So it's very Mac based, protocol based, what port, what's being done, what, where, what the flows look like. Right. Just a diagnostic tool. Other things you can do in the controllers, there's various configuration options for you can set users, different user levels. You can define custom protocols. So if it's a protocol that you've run across that we don't have in the network, it's very easy to create a new protocol and define it, and then we will recognize it from then on. The controller does understand VLANs. So for example, if you have devices, if you plug a higher level network into our network and you're using VLANs on that port of whatever switch you plug it into on the enterprise, we will auto recognize those VLANs on that port and be able to communicate back and forth as needed on those. As well as if that port we're using spanning tree, even though we don't need spanning tree on the SDN network, we can talk spanning tree on that particular port. So it makes it very, 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 very flexible. Other great tool is have you ever had to span port a bunch of switches to try to understand why something's not communicating properly? This is a great way to do that. Now I just got to notice that we have 5 minutes left in the meeting. So let's jump over to the new UI real quick, just so I can show you some of the differences. And then, of course, we'll probably have questions. So as you may have guessed when I showed you this larger network, this is the new user interface. I happen to be using one theme. This is the light theme. So you can change the themes around. I'm a dark theme kind of person. The topology page is different. It's more organized automatically. When you regenerate, it actually gives you a drawing that is much clearer and makes a lot more sense. We've done a lot of work with that. We also have the ability with the new UI, probably not right at its initial release, to do things like show me Modbus TCP communications. And it'll highlight all of the devices and all of the paths around the network that are talking over Modbus TCP or Ethernet IP. So it gives you a great deal of visibility into the network. Nothing on zones that's interesting. The switching page is most of the pages now have this look and feel. You'll notice this is much like other products, where you can edit devices and do different things. This is a virtual network that I'm looking at. So it's running in something called MiniNet. So if the numbers here look kind of funny to you, disregard them. The controller does not care about IP addresses. You can mix and match IP address ranges in the same controller and have 5 separate complete networks with one controller. It doesn't care. All it cares about is MAC addresses and low-level layer 2 traffic. So in my simulation, I don't bother to change the name, the actual IP address, because to the actual controller, it's irrelevant. Some of the things we've done, and a minute ago, you saw me look at the flows. Well, one of the things we've learned is oftentimes when we're tracking through flows, we want to see the flows from these two devices. So now I can group, I quit clicking so fast. So now I can group my view to cover multiple switches like this, and I can see them. And I can even put compound statements in here. I can say, I think this is in the build I have. I can do ICMP. Okay, don't have that. I can do SIP. Oops. I can learn how to type. Okay, so I don't have any of that on those two virtual switches. But it would actually let me find things. I could do SIP, comma, ICMP if I had it in here, right? And it would show me those flows as well. So a lot of power. We have this concept called cross-domain routing. It's in the controller. I didn't mention it before. It's kind of like allows you to NAT through a switch. It's the same idea. I can have one broadcast domain on one side, one on the other side. Other things, you'll notice the menu is just a little more concise. The devices list, all of them look like this, right? I showed you that switch list. I can export the list now, so I can export it to CSV if I want to pull it into something else. Editing, viewing, hiding, quarantine a device. If I quarantine a device, that means it's not allowed to talk on the network. Rockwell PLC, for example, we fingerprint that PLC. That means if it's, we know that it's this MAC address, this firmware revision, this serial number, although we don't use firmware in the fingerprint, this Rockwell product code. If we see that device come onto the network and all of those characteristics don't match what we know, the device is immediately quarantined. Maybe it comes on with a product code of 5 and it should have been 13, which would be a COM adapter. And it's scary that I know that. But it would automatically get quarantined. And then you can look at the policies page, policies and rules. And again, I mentioned we've got this nice window is what we do all of our policy creation. And if I happen to know it, right, I can say allow proto, ICMP on any. And I know that it's good because I put that in there. So that's good. Other things, configuration is much cleaner now, just a lot of condensed, organized. Different maintenance capabilities now that are built into the controller, users, protocols. We can schedule policies on and off. So you could say, allow IT to do their SUS update stuff on Tuesday nights from midnight to 2. And so you can turn on the flows that happens when that happens, and you can turn them off when you don't want to. Integrations are letting those third-party apps in, right? Some controller specifics, and then how things are licensed. Still have the logging capabilities, all the different things I do on the virtual network. So just generally speaking, the biggest play is going to be all the things that we can do with the new topology view. It's going to make it very, very versatile, very, very flexible. So I think that's close to the end. Do we have any other questions that I need to answer before we wrap up? So I don't want to fill up the entire time with conversation.
We have a good bit of questions.
They must be in chat and not under QA. Let me look through.
No, you just have to hit the repost on QA. So the first one is
new post. There we go.
Yeah. How will replacement work in case of a switch failure? Add a new switch and flows get pushed from the controller to the switch, or does it require relearning?
So good question. When you replace a switch, you don't have anything else to do other than adopt the switch, which tells the controller it's okay to talk to that switch. All the flows will be pushed back to the switch. As any device starts communicating, that first packet goes to the controller. The controller says, I have policy for that, and it writes it out to the switches. So you don't have anything to do once the switch is replaced. The controller will take care of that. We do have this idea of a concept where we can snapshot all the flows in a switch and be able to explicitly push a set of flows down to the switch, even without waiting for any of the traffic to show up to the switch in the controller. It's really a matter of milliseconds in terms of functionality. I mean, honestly, if you've just replaced a switch and it's a minute, let's see if it takes as long as a minute, which it wouldn't, for all the flows to get written down to the switch, you just replaced a switch. So it's really not an issue. So there's no relearning required. It just needs to see the traffic to write the flows. If it doesn't see traffic, then it won't write the flows. But yeah, just replace the switch and the network will take care of the rest.
All right, next question. In case of multiple OT SDN controller scenario, can we export and import the rule set between controllers?
So today in the old UI, you cannot, although we can move things between controllers. We have customers that do that. In the new UI, you'll be able to, instead of doing the whole database at a shot, you'll be able to import and export pieces of the architecture that you want. I think I mentioned that there's an option now for, exporting any page that's in here, right? So that gives you that ability. So yeah, we're going to make it a lot easier to move things around from a policy perspective.
Okay. Question number 3. The OT controller knows the traffic in end devices. Does it support/keep the asset inventory of the network devices, switches, PLC, etc., and information, MAC address, vendor, etc.?
It does. So if it's something that it can pull that information from. So in the case of, I'm jumping between stuff. If we open this device up and look at it here, right, this one's been on the network for a while, so I can see things like it's Rockwell Allen Bradley, it's got this serial number, and there's actually more detail available that we're not specifically showing. I don't think we ever put it onto this page here as well, but yeah, we have all of that asset detail, and we're constantly adding more of that ability to deep dive into the network to pull out the details. But you get a live asset. If I plug something new into this network, it's going to show up in this list, and then I'll get any details that we can glean from the device.
Okay, next question. I will take this question. Where can I find information at Dynex.com on OpenFlow Industrial Ethernet switches? We have a product page on our Flex Connect switches. Jay, I will get that information over to you. And now we're on to the last question. Does SDN support NAT?
So no, there is no idea of network address translation, but we do support, and we have a feature. Actually, we built this feature for General Motors called cross-domain routing. And what that allows me to do is I can have a switch, and maybe the PLC is on the 10 dot address range, or in your case, Callion, it's on the 10 dot address range. And then all of the devices, for example, at General Motors are 192, 168, whatever the rotary wheels are set to, or in your case, 172. And then the controller can talk on the 10 dot address up to the rest of the network. I'm doing hand gestures like you guys can see me. And then it can talk, 192, 168 down to the devices below the switch. So it's not natting, but effectively provides the same kind of behavior, and then actually some more capabilities you can't do with NAT.
All right. That is all the questions.
All right. Well, if there are no more questions, I think we're at our time. We're 1 minute and 48 seconds over. I appreciate everybody's time today. Hopefully you learned something new. Hopefully this might spawn some more questions. You know how to get a hold of me, jsmith@dynex.com, and happy to answer more questions. And you guys have an excellent day. Chris, you have anything else to wrap up with?
No, I think you said it. Thank you, everyone. We're going to do this monthly. As new things roll out, we will add them to the demo. Thank you for the very good questions. They allowed us to get deeper into the usability of the tool. And we'll follow up with all of you and look forward to working with you. Thank you all.